Welcome to the Explainer. Today, we're going to get into a really cool framework that promises to make the AI on our phones feel, well, truly instantaneous.
So let's start with something we've all felt, right? You're trying to use some smart app. Maybe it's identifying a plant or translating a sign on the fly, and you get that lag, that little pause that just kills the magic. The app feels sluggish. So why does that keep happening?
Okay, so this chart really lays out the core of the problem. You can think of it as the AI latency trap. Now look at that first bar. If you try to run the whole AI model just on your phone, it's just too slow. We're talking over 2 seconds. So you think, okay, let's send it to the cloud. Well, with a great signal, yeah, it's blazing fast. But if you're on low bandwidth, look at that. It's actually slower than doing it on your phone. You just can't win.
So that's the trap. You're stuck. But what if there was a way to get the best of both worlds?
Well, the solution starts with this idea called edge computing. Instead of sending all your data on this long trip to some far-off cloud server, what if we just brought a powerful server much closer to you? I mean, think about your local 5G base station, or even your Wi-Fi router having some serious computing power. That's the edge of the network.
And this is where a framework called Edgent comes in. It's built specifically to use these nearby edge servers. And, the key word here is collaborative. Edgent doesn't just offload the entire task. No, it creates this smart partnership between your phone and that edge server to get the job done as fast as humanly or, I guess, artificially possible. So, how does Edgent actually pull off this perfect partnership? Well, it really comes down to 2 very clever techniques. You can think of them as its 2 secret weapons, splitting and sizing.
Its first secret weapon is something called DNN partitioning. Now, a deep neural network, or a DNN, is made up of lots of different layers. What Edgent can do is look at all those layers and figure out the absolute perfect spot to slice that model right into.
The whole thing works kind of like an AI relay race. Your phone starts the race, but instead of trying to run the whole thing, it passes the really hard part, the heavy computation, off to the super powerful edge server. The server does all that heavy lifting and then passes back this much smaller, really lightweight piece of data, like the baton in a relay, for your phone to just easily carry across the finish line.
But what if your network is still a little choppy? What if even that relay race is taking too long? This is where Edgent's second secret weapon comes into play, DNN right sizing. And this is all about knowing when an answer is good enough so you can stop early.
You see, the AI model is actually trained with these special early exit points. So as your data is flowing through the network's layers, the model is constantly asking itself, how sure am I? If it gets, say, 95% confident that it has the right answer after just a few layers, Edgent can just go, yep, that's good enough, and return the result, skipping all the remaining work. It's kind of like getting off the highway at an earlier exit because you're already close enough to where you're going.
And this quote from the source material really gets to the core of what Edgent is trying to do. It's a constant balancing act. Inference accuracy is just a fancy way of saying how good is the AI's answer. So Edgent's whole job is to get you the smartest, most accurate answer possible, but, and this is the key, without being even a single millisecond late for its deadline.
But a system this smart also has to be adaptable. Because let's be honest, in the real world, our network connections are messy. They're all over the place.
And Edgent actually has 2 different modes for this. In a nice, stable environment like when you're on your home Wi-Fi, it uses prediction models to figure out the perfect strategy right there on the fly. But in a more dynamic, messy environment like walking down the street on a choppy 5G connection, it switches to a pre-computed playbook. It senses the network has changed and instantly grabs the best strategy for that exact condition right from its math. No heavy thinking needed, just instant adaptation.
Okay, so the theory sounds amazing, right? We've got intelligent splitting, we've got early exits, we've got this real-world adaptation. But does any of it actually work? So the researchers set up a test to mimic a real-world scenario. They used a Raspberry Pi to act like a mobile device and a regular old desktop PC to be the edge server. They gave it a standard image classification task with a very clear goal. Get the most accurate answer you possibly can, but you absolutely cannot miss your time limit.
And wow, the results are pretty striking. Just look at that middle column, the 300 millisecond deadline. Trying to do it only on the device, it fails. Sending everything to the edge fails. Even just using the smart splitting trick by itself still fails. It was only Edgent, with its ability to both split the model and take an early exit when needed, that was smart enough to hit that tight deadline while still giving a really accurate result. The other methods, they only started working when you gave them a much bigger time window.
So this is a pretty big deal. The success of this experiment isn't just about one clever framework. It really points toward a future where this kind of on-demand collaborative intelligence is just built into everything.
I mean, what does this kind of thing actually unlock? We're talking about augmented reality that feels truly real and interactive, not laggy and disconnected. We're talking about industrial robots that can react in an instant on a factory floor, security systems that spot a threat in milliseconds. It unlocks AI that isn't just smart, but it's there the moment you need it.
At the end of the day, the big takeaway here is a fundamental shift in how we think about our devices. We're moving away from a world where our phones are just simple terminals for some big, distant brain in the cloud. Instead, they're becoming active partners in an intelligent network, able to tap into incredible power that's just a stone's throw away.
And that really just leaves us with a final question to chew on. When that lag is completely gone, when every camera, every sensor, every microphone has access to instant, powerful intelligence, what are we going to build? What new experiences will we create? The possibilities are really, really exciting to think about.